The question is, what is the temperature of a gas at 500 millimeters of mercury and 750 milliliters if it was at 55 degrees Celsius, 0.8 liters, and 1.2 atm? First of all, let's write down our information. What is the temperature of a gas? So they want to know the temperature, T1 equals question mark. Then 500 millimeters of mercury, that's a pressure. So P1 equals 500 mmHg. And 750 milliliters, that's a volume. So our V1 equals 750 milliliters. Then we have another temperature, 55C, so that'll be our temperature 2 equals 55C. Then we have 0.8 liters, that's a volume, so that'll be our volume 2, 0.8 liters. Last, we have 1.2 atm, that's a pressure. Our pressure 2 is 1.2 atm. Now, we can notice some things about this immediately, namely that our pressure units don't line up. Also, our volume units don't line up. And lastly, our temperature units are not in Kelvin, so we want to convert those. Let's start by doing some converting. We can either convert 500 millimeters of mercury to atm or atm to millimeters of mercury. It doesn't matter. I'm going to convert 500 millimeters of mercury to atm. That means millimeters of mercury go on the bottom and atm go on the top. There's 760 millimeters of mercury per 1 atm. That means my atms are going to equal 500 divided by 760 equals 0.658 atm. That means this mmHg becomes 0.658 atm. Then I'm going to convert the milliliters to liters. Again, personal preference. 750 milliliters to liters. That means my milliliters will be on the bottom and my liters will be on the top so that they can cancel just like my mmHg canceled to equal my answer. For every 1,000 milliliters, there's 1 liter. 750 divided by 1,000 equals 0.75 liters. That means this 75 milliliters is 0.75 liters. Lastly, the temperature 2 needs to be in Kelvin. So I'm going to take 55 Celsius plus 273 equals my Kelvin temperature, 328. Therefore, this is 328 Kelvin. Now let's erase our conversions so we have space. If you are confused by the conversions, you should go back to pressure conversions, which is the first one, then unit conversions, which is the second one, and finally temperature conversions. These are all different sections in my website. You can use the search to find them. This is one group of information. So this will be one ideal gas law. PV equals nRT 11111. This is another group of information. So this will be another ideal gas law. P2V2 equals N2R2T2. Now we can cross off everything that doesn't appear. We have a pressure for this guy, we have a volume for this guy, and we have a temperature for this guy. We don't have moles, we don't have R. Now for the next one. We have pressure, we have volume, we have temperature. We don't have moles and we don't have R. That means we're left with P1 V1 equals T1 and P2 B2 equals T2. Now we can't make these guys equal each other right away, but we can always modify them like we did last example. Divide both of these by T2, and that gets rid of the T2 on that side. Divide both of these guys by T1, and that gets rid of the T1 on that side. Now we can equal them. P1 V1 over T1 equals P2 V2 over T2. This, of course, is the combined gas law. That's the name for this equation. But again, you didn't need to know that to solve this problem. Let's put in our numbers. P1 is 0.658 atm times V1, which is 0.75 liters, divided by T1, which we don't know, equals P1, which is 1.2 atm, times V1, which is 0.8 liters, divided by T2, which is 328 Kelvin. Now, how do I solve for this? How do I solve for my T1? My first goal is to get it on the top in the numerator. Doesn't matter the side of the equation. So what I'm going to do is I'm going to multiply both sides by T1. Then I'm going to have 0.658 atm times 0.75 liters, and our T1s have crossed out, so I don't need that, equals 1.2 atm times 0.8 liters divided by 328 Kelvin times all that by T1. Now I want to get everything, all of the numbers and units away from T1 and leave T1 on one side of the equation. The way I do that is do the exact opposite of each of these operations here. So that means I'm going to divide both sides by 1.2 atm and 0.8 liters. Same thing on this side, 1.2 atm and 0.8 liters. Then I'm going to multiply both sides by 328 Kelvin. That means we cross out the 0.8 liters here, the 1.2 ATM here, the 328 Kelvin here. Therefore, we are now left with 328 Kelvin times 0.658 ATM times 0.75 liters divided by 1.2 ATM and 0.8 liters. All of this equals RT1. What units will RT be in? Well, we're getting rid of ATM, we're getting rid of liters, so our T will be in Kelvin. T1 equals 328 times 0.658 times 0.75 equals divided by 1.2 equals divided by 0.8 equals. The temperature is going to be roughly 169 Kelvin from my Kelvin units here. That is your final answer.